Right, welcome back to the world of computer electronics 206. I am recording the class with a little camera here so that online participants can watch it either. Actually, it is supposed to be live. It's called YouTube Live. That's a new feature they have added to YouTube now. Used to be called Google Hangouts. I guess it's still linked together somehow together with this other application, but it lets you take anybody take a webcam and set it up and record, or camera, and record a presentation or meeting of something like that. So right now, those who would watch this later would see what's on the screen there at the moment. And this is what the other screen looks like. You see what happens when I put that on the screen? It does like a mirror thing there. It goes crazy. So that's the screen that is being being recorded there right now. Let me get back the slideshow going again. There we go. So that's called Google Live, or Google used to be called Google Hangouts. They just switched it to Google Live a few days ago, and works pretty much the same. It hasn't changed much. If you go to Google Hangouts, it's still there. It's just linked. You just renamed it. But it's a pretty nice idea. You can record something like a meeting, or you can actually have multiple participants. And you see quite a few videos on YouTube made with Google Hangouts or Google Live, where people have a meeting or some kind of a talk show, or all kinds of neat things people do with it. It's a pretty neat tool. So what I wanted to do again today is just explain a little bit about, first off, about the online part of the class and why I changed a few things over the summer. Just a couple weeks before the beginning of the term here, I found out I was going to be teaching it online. I'd never done that before, and so it was a kind of last-minute decision on part of my dean, our department, and I hadn't really anticipated doing that at this point. I have not been running this class online at all, and really didn't anticipate doing that this semester. But as it turned out, they asked me if I could do that. And so I said, well, we'll do it, but I'm going to keep things pretty simple. So that's why I'm trying to keep things as simple as possible. I'm not making things very complicated, although you might be still a bit puzzled about things. So I just want to clarify to you that I'm trying to make things simple as I can, not to make things complicated. We have two online resources that we primarily use for our class, and that is the class website, which you see on the screen right now. By the way, let's just say hi there. I had my screen on, so I am really here recording this. They're seeing me on the screen now. I'm going to switch back to the other view again. So we have this class website, and it's course management system. If you've used Blackboard, things like that, it's like that. It works like that. It has a built-in grade book, and I'm using a system called Moodle right now, which I like a lot. Works great. Moodle is a very popular course management system used in schools and colleges all over the world. College MJC is now starting to use one called Canvas, which is very similar. I am learning about Canvas, but I'm not familiar with it, so I'm staying with the one have been using for my class. This wasn't an online class before, but I used it for my class to organize things. I would just put everything that we do on our class website, and that's why I asked you to create an account there so you could access that, and I just post everything we do each week. Not that it's very complicated, but it does help to keep things organized a little bit. So what you see there is just the front page, and I could put put a few things on there. There's a syllabus. There's a link to Test Out. That's our other online resource. And asked everybody to get a subscription to this online textbook. It's not really a textbook. It is like a textbook because it has a table of contents and it has various chapters and sub-chapters, but it also has videos. It has simulations, which is probably the most interesting part of it, is the simulations that let you do things that an IT technician, information technology technician, computer technician do. You would do them with the simulations. And it has also quizzes and videos to watch. So that's what that is. And let me show you that. So I'm logged in on Test Out here. Okay, here's Test Out, right. So we have that as well. So that's also on the internet. You can use that to do our homework for the class. And if you haven't done so already, I did ask everybody to get this subscription as soon as possible, but I realize that there are sometimes circumstances where you might not be able to get it the first or second week. So I understand that. But we want to, this is our textbook, so there is no other textbook to buy. So you want to, yeah, come on in. So you don't want to, we do want to use this. This is our primary resource. It is a great training aid to, it's centered around passing the A+ certification, the industry, one of the most popular industry certifications for computer technicians. And that's what it's all based around. So if you've got that all working, you're in good shape there. Subscription is all working, so you should be able to participate in that part of the class. So, and let's see here, go back to this. So then I do is on our class website, each week I put up a topic box for each topic. I've explained all this again, but I know I'm repeating, but that's okay. Sometimes it isn't real clear to everybody the first time through. So I am here. We are in the third week already, and I'm saying it again, but that's okay. I think it's not bad to repeat things a couple times. But I put on there the each of these boxes. There's the topic of this week. That's number 3, and you can change the topic. Down here's a menu, or you can click on this button here. That'll take you back to, like if I go click on that, that'll take you back to the previous topic, which was last week, which is hardware basics. And then you can go to any of the topics with this drop-down menu here, like the first one, getting started. Just explain how to get started in the class. And so each week there'll be another one of these topics that will appear on there. And in each topic box, there will be a list of the things you should do in Test Out. The first week I asked you to do 1.1 and 1.2. Those weren't very big ones. The first one was just telling you about how Test Out works. And Test Out is pretty simple to use, but it explains how to use it. And so that was the first lesson. And then the second was how to use the simulation part of it, the lab simulation. And then on week 2, there's a lot of stuff here in that box because it explains a project. But in week 2, we did 1.3, which is hardware basics. And then here in week 3, you see the first recorded lecture I did with the Google Live, or Google Hangouts. I have it recorded, so you can watch that later if you want. And I'll just repeat it, will be what I'm recording right now. And I put the slideshows I show here that I showed you and some other things. And And in this topic here, I have a description of our project. Now, the other difficulty I had to consider is when making an online class like this, if some people were not able to participate here and they didn't have access to the equipment that we have in our lockers there, which is a computer, then how would they participate? Well, they're going to have different equipment. So in the past, I've had labs where the projects were using the same equipment, everybody using the same equipment. We do have a bunch of Dell PCs, similar to the ones underneath the table. Not older ones, not quite the same model, but very similar. And so we all had pretty much the same computers. There were some variations of them, but now we don't have all the same computers. So it is going to be a little different. I can't depend on that. So this is what's referred to as project-based learning, which is the idea that you take on a project of some kind, which is something that's open-ended, meaning it doesn't have an exact way to do things. There's many ways you could do a project of some type. And this is the case here. There's no one way to do this project. But what I asked you to do on this project is to identify the name and the function of the parts of a computer. One of the first things that one should learn when you're dealing with personal computers is what all the different parts are, what they do, the function of those parts. And so that's what Test Out deals with as well in one of its lessons here called Hardware Basics. It talks about the different parts of a computer. And so I listed some of the common parts you'll find in most computers. This first list, especially, you would find most all of these parts on almost any computer. And then also some of the connectors and connections that you see for different devices that you can connect to a computer. Now, the connections are not necessarily in every single computer. There's lots of different variations on what different computers have. So this is not by any means a list of the parts that you'll find on every computer, because they're all different. But there's some of these are very common ones, and some aren't so common. So what I'm asking you to do for this first project is to prepare a presentation about the parts of your computer that you identify inside and outside of your computer, whatever computer you choose to use. So again, we have the ones in our locker. You may use those. But you may have, if you're participating online, then you have a different computer. So you would choose that. And what we're asking you to do is to give a tour of your computer. And I would like to ask that you show at least 20 different parts, 20 different things inside your computer, different devices how it functions in there. Each part, I'll give some points to each part as 10 points. 5 points for identifying the part correctly, and 5 points for describing its function. So it's a relatively fast-paced presentation you're going to make. It's not going to dwell too much on any one of these parts, but 20 parts times 10 points per part gives about 200 points. An additional 50 points will be for the quality of the presentation. You need to have good, clean, sharp video. That's worth 10 points. The slideshow should have good quality sound. You're going to add sound to your slideshow. And each picture should include captions that include the name of the part and its function, because you can't be sure that people can hear that are watching your show, or they just might want to watch it as captions. Now, there's a closed caption function in YouTube that you can use for this. Meaning that you can turn it on or off if you want to make it so that the person watching your video has captions. They can turn it on, or you can have them turn it off. And that's called closed captioning. So that would be a feature that I would use for that. Or you you could also put the words right on the slideshow itself, in which case the captions are there all, no matter what. You can't turn them off. And that's okay too, if you want to do it that way. There should be an introduction to the slideshow with your name on it, and just telling what you're going to present to the audience, and also a little introduction to what computer you're going to, just a general picture description of the computer that you're going to give us a tour of. So for the slideshow, I described there how you want to use some kind of slideshow program such as Office 365, which is you have access to through your MJC account. It is when you log into your email through mjc.access that. Let me show you that if you'd like here, just to clarify that to you. So if I open another tab here and I go to mjc.edu, and if I then log into my student email, and well, this computer already knows me, of course, but yours looks the same, much the same. You have a username and password. But once I'm logged into my email, here is my email. Okay, I can click up here on the top. There's a little button there, and with a little square, the squares, and that is accessing the different apps that you can run. So different apps are, one of those is PowerPoint. And this is part of what they call Office 365. It's kind of like the online version of PowerPoint. And you can make a slideshow with it. So that is one option there. It's pretty easy to use. Another option would be to actually use the PowerPoint that you install on your computer. Rather, this is what they call cloud-based program, meaning it's downloading it and running it in your browser. So there's also the regular PowerPoint that you can install on your computer, or another program that is free is called OpenOffice or LibreOffice, and that's a slideshow program as well that works really well. In fact, I use that a lot myself. Just show you what that looks like here. Yeah, that's what I am. This is, minimize that. Here's, I have a slideshow loaded on it, but this is called LibreOffice, and it's a lot like PowerPoint, and it's free. You can download it for free and run it. So those are some options, and there's others too, but just some way that you can show your pictures. Of course, you can add text, and you can do all kinds of nice things. You can add animations and all sorts of things. Now, the PowerPoint slideshow is itself not a video. It's a slideshow. It's run in the slideshow program. But to make it into a video, then what you do is record it. Record your slideshow. So you're going to present your slideshow. For example, I'm going to do that right now myself, right? I mean, a little while. I've got my slideshow there. I'm using my LibreOffice here. But I could record that slideshow and then upload it to YouTube. Right? I mean, I chose YouTube because it's certainly the easiest one to use, or one of them. There's other services too that one could use for that. It doesn't have to be YouTube, I suppose, but I think it works well for this purpose. Now the question is, how do you record it? Well, one way to record it would be to do exactly what I'm doing right now, and that is to record it as a Google presentation. You could do that. That would be one way to do it, as what they call Google Live. You could record it right off the screen because it does that. And you could record your whole presentation that way, that would be one way, because you've got your slideshow set up. It records whatever's on the screen. In Google Live, I can select what I want to show on my screen. Let's see here if I can. I guess that's what I'm on right now. So, show you the screen with Google. With YouTube. There we go. This is the screen that we're looking at. And you see when I pull it over there, it starts doing the mirror inside the mirror trick, because it's seeing itself. It's like looking in a mirror. So, but that one is that one you could use. Another one you could use to record that's really convenient. A lot of people use this. It's called Screencast-O-Matic. That's a Screencast-O-Matic. It records your screen and whatever's on it, and you can have it also record from a webcam, like I'm doing now, or you can record it from both at the same time. Lots of neat things you can do with this, and then it even lets you upload your video directly to YouTube from that program. So it's very convenient to use. You do have to create an account with it, but it works very well. I've used that quite a few times myself, and there's other ways too. You can get special programs that run in your computer to record your screen. Those are just two possibilities that you could use. And it's when you're recording it that you add the sound. That's when you would plug in your microphone. If you have a webcam, if you have a laptop, it's already got a microphone built in. If you've got a webcam, it's got a microphone built in, most likely. And you can use that to record it, or you can plug in a microphone. There's microphones don't just plug in the microphone into your mic input jack. Any computer, almost any PC has a mic input. Here's a really inexpensive little microphone that you could use to record a slideshow. Since you're not really needing to have your picture, I mean, you don't have to have your picture live on the slideshow necessarily. You could, but if you don't have a webcam or something, all you really need is a microphone beyond the pictures that you put on your slideshow. And so you're going to be recording the slideshow and adding the sound. Now you might have to do a little research with your particular setup to make it all work right, to get your sound working and everything. You might make a couple test videos and so forth. But again, this is a project, so I'm not able to explain to you exactly every detail of everything, because every situation's different. But that's the nature of being an IT technician. A person who helps people with computers often runs into situations that they don't know what to do, right? We don't always know what to do, so we have to do research. That's part of being a person who helps people with computers. Nobody expects everybody to know everything. Now, the idea of the A+ is that there's a body of knowledge that should be common to most people when they're working as a type of IT technician, information technology technician, or support person. That there's a common knowledge that we should know, and that's what it tests you on. It's equivalent to, say, working as an IT technician for about a year. So if you go through test out, it gives you that experience. So that's the idea. It's supposed to give you the experience to pass the A+, so you've had that 1 year of experience. And certainly taking a course like this, along with, there's a companion course that continues, that would be a very similar equivalent experience. It's not likely it's exactly like you'd worked a whole year on a particular job as an IT technician, but it's in that, it's just generally saying that we've had an experience. So the idea then is the A+ is equivalent to that. it says that you have a commonality of knowledge that you find common to people who work in that field. Not that you know everything, no one expects that. But it does give you that commonality. It gives you a base from then to grow. And you would then be able to use your skills as a researcher and learner to continue learning. You're always going to be learning. You cannot say that this is a static field because it's constantly learning. And you will too. So it's always changing. Okay, so I hope that gives you a better explanation of the project that we're doing for this class. I did give it a fairly generous amount of time, I think, for the project, and that's the remainder of this month. This class, we have till October 3rd to complete it, that being our deadline, and we'll be beginning another project right around that time. But I know it takes time to get up to, it takes time to learn how to use these different tools. So that's why I said on the explanation on the class website that expect this to take a good number of hours, maybe 8 to 20 hours. It depends on your level of experience and background. It does take a bit of time to make a video, a good slideshow and a good video. Put a presentation together like that. Maybe it wouldn't take you 8 hours. Maybe it'll take you less than that. But to do a really good job, I would think you need to think about considering that a fairly sizable project. Let's see here, get my right. So that's what I'm describing here. It's a big project, worth a lot of points, and we basically have 3 weeks here to do it. So go ahead and get started. What's the first thing to do? Find your computer that you're going to use, some kind of computer. What if you simply don't have access to any computer? Now this would be another option for you that I listed here. Another option is to use the simulated computer that's in TestOut. There is a Dell computer, very similar to the one we have in our locker, in the simulation. You could use that as the basis for your slideshow and give us a tour of that computer. It does have all the parts represented. And you can zoom in on the parts. You can go, look at them very close up and all this, and it's actually a pretty good way to go. I would prefer, though, if you'd use a real computer, if you have one available to you. And I'd like to have a variety of different computers. So that would not be my first preference, but if it absolutely is the only option you have, and I'm speaking only section of the class, or you only have a computer you can't take apart, you don't want to open up, like a laptop. Laptops sometimes aren't very convenient for that sort of thing. And sometimes, in fact, you take a laptop apart and if you haven't had a lot of experience with working with laptops, you'll find it can be difficult to put them back. To ruin your expensive laptop for this project, if that's a concern for you. You can access some parts of the laptop quite easily. You can get into the memory module area or the area where the hard drive is. That's usually fairly accessible. It depends on the model. Now, if you're talking about some of Apple machines, they don't make it very easy to get into them. So, for example, some of the real smaller machines that they have that are real light, thin, they don't really make them easy to get into necessarily. And in the future, I think that you're going to see that as time goes on, computers are going to become less and less designed to be taken apart, especially portable ones. Now, desktops, I think, will be around for quite a while, but the laptop and so on will be computers that will become more and more, well, basically when they fail, you replace them. And you might be able to change the storage devices and the memory on them, and that might be all that you would. But even some computers, you don't have that option of changing you just have what you get is what you have, and then if you want to upgrade, you get a new computer. So do you any questions if anybody have about the test out or anything like that before I pretty clear about how that all works. Is there anybody having trouble getting into the test out? And this is to people at home too. If you're having difficulties, please contact me. You can send a message to me very easily through the class website or through email, or you can call me, leave a message on my phone. I have your phone numbers listed in my syllabus. But if you're not, it is meant to be pretty straightforward. You do need to make sure that when you join the test out, that you join Modesto Junior College. It will list Modesto Junior College there as one of the colleges when you get your test out subscription, and you want to also subscribe to our class under my name. There's the teacher. There's more than one teacher using it at MJC, so you want to make sure you choose Tim Vaughn, not the other instructor, because you'll put yourself in his class and he'll see you on his when he logs in, and not instead of me. I want to be able to have you in my class, so make sure you join our class. All right. I want to talk about operating systems today. The topic in test out is operating systems. And I'm going to add a little bit of my own to this topic. So here we see a picture of a fellow using a very old computer. And this is kind of a famous picture because this is one of the first computers to employ a real operating system. A computer does not have to have an operating system. What is an operating system? An operating system is a program that runs inside a computer, or actually a set of programs. There's usually consists of many programs that work together to allow a person to more easily use a computer. All right, well, it's possible to have a computer that doesn't have an operating system, which means that you would just load a program into it and make it run. And that's usually nowadays, there are computers like that. Usually they're small computers that do small jobs, little computers that you might find inside of other electronic devices. But most big computers that you use, personal computers, do have some kind of operating system. Of course, if we think of operating system, we usually think of Windows or Linux. Those would be the two most popular ones out there, or Apple iOS. And that's another one that's very popular. Those are names of operating systems, and there's many more than that. So what is the operating system? What does it consist of? Like I said, it's actually a series of programs. It's not just one program. It is many programs that work together. And all of these different programs work together through a central control that controls everything else, called the kernel. It's like the core of the operating system. So Windows, for example, has a kernel. And you can talk to that kernel, and we'll see how you can do that. You'll see that it's part of the A+. You learn about communicating directly to the kernel. There's a way of typing commands and talking to the kernel using a text-based interface. So you can, but then we also have the interface that the user usually sees, which is usually graphical in nature, which is the one you use with your mouse. And that's called the user interface. And that's part of the operating system as well. So we have here the interface. The interface is what communicates with the kernel. The interface makes the operating system easier to use. And when you think of an operating system, you're usually thinking about what the interface looks like. The interface is what you see on the screen. But you really are just, the interface is what lets you use the operating system more easily. Makes it more friendly. And you don't really have to have an interface that's anything fancy. It could be very simple. You also need, an operating system also provides some way to organize information. And after all, what does a computer do for a living? It's processing information, data. And it needs to have a place to store that data and organize that data. So for that reason, the operating system provides a file system. Files are pieces of information of different types of data that are put together and stored in an organized format. Really, ultimately, files are large numbers of bits and it's usually organized as bytes. Bytes are 8-bit chunks. So most files you see on a computer, and this is true of Apple iOS, Linux, and Windows, they pretty much all do the same thing this way. They store things as files of bytes. So when you load something when you get something to process in your computer, to run it on your computer, whether it be a program that runs or the data that program processes, it comes from the file system. The file system organizes that information for you and keeps it so that you can find it. Another aspect of the operating system is the computer management. Managing the computer, meaning all of the functions and features of that computer, you can make changes to, settings of different types, hook up new hardware, install new programs, make changes to the settings of the operating system itself. That's usually always that's a part of the operating system as well. So there's some way to change things and add new features to the computer management and manage the resources that the computer provides you. And then another aspect of operating systems is security. Security being, how do you keep different users of the computer from either purposely or unintentionally interfering with another user, with their data, getting access to their data. So, for example, Windows lets you log in. A little while ago, when I started up my computer here, I had a login page, and I had to select which user I was, of course, and have my password. I have access then to my files that I have stored in my way that I have my setup, my operating system set up for me, and then other people would log in and they'd have their own files and their own setup. So that's part of the operating system as well. Now, these different aspects of the operating system are layered. They are layered, and at the top of our layers, you have the user. The user is you, right? The person using the computer. The user communicates to two different things. The user communicates with the operating system, or the user communicates with the applications, the software that you're running, the various programs. So that's what you interact with and you see. Now, the software, in turn, interacts with the operating system. So you can interact with the operating system, but so can the programs. And whenever the programs need to do things like put something on the screen or access some resource that the computer provides, let's say send something to a printer or get some input from the mouse and the keyboard, the application software does so through the operating system. It communicates with the operating system to get its resources. Now, that isn't always been the case in the past. In some early personal computers, the application software could access the hardware directly, or it could access something called the basic input-output system. So that was the way it was in the long past, like maybe 30 years ago. What that meant, though, was if if the hardware changes in some way, then that meant that the application software would also have to change to take care of new hardware. If a new version of a computer came out, you know, it was okay as long as you were just running the software on one computer, one model of a computer. You know, at first there was say the IBM PC, and you could run IBM personal computer, but maybe it wouldn't work on another model of a computer that was designed by another company. When I mean IBM PC, let me show you what I just Google a picture here of the IBM PC. This computer is the great-great-grandfather of the computer that we primarily use in this class. It is the original IBM personal computer. So that's where the name PC came from. Although people did talk about other kinds of computers that they also referred to as personal computers. But this computer was the great-great-grandfather. Now, there was a time when people would write software for this particular model computer, and it would only run on that computer. Now, this computer, though, is still, or I should say computers today, are backward compatible with this computer. If you have a program that would run on this old computer, you can still run it on the latest models. So like these computers in here, relatively new computers, on that old computer there, and still run it today. Even the latest model, you know, i7 processor, Intel or Xeon or whatever, you can put the software that would run on this machine and it would still run. Since they maintain backward compatibility, and there's no reason to believe that won't continue into the future. So if you get programs that you use today, 20 years from now, you'll still be able to run them somehow. Might not be, you know, might be some kind of virtual computer, a simulation of a computer that runs it, but it'll run it somehow. And that's still the case. Now, when I say personal computer, I mentioned there were other personal computers out there, and I talked a little bit about that in the history of the personal computer last week. Talked about different parts of the computer, but like, for example, another real famous personal computer was the Commodore 64. Very, whoops. Look, you can still buy it. $32. What's that, used? I don't know. Anyway, images. But this was all, it was Coffin software, and it had an you could install an operating system on, but it wasn't compatible with the IBM PC. So it ran different programs. The programs had to be written specifically for that. So that's a totally different computer there. Now, yes, sir.
Monday, talking about these models, the IBM PC runs with a processor 8088, and this Commodore runs with C80. That's where the operating system was not compatible.
That's true. This had a different processor than the IBM PC. Mm-hmm. The IBM PC used a processor, like you said, the 8088, mm-hmm. and this, which is
C80.
Where this one used, well, actually, this one didn't use the Z80. It used the 6502, another processor. Mm-hmm. There was a lot of computers that did use the Z80. Like my first computer was one of these, TRS-80.
Oh, yes.
Very famous old machine that lots of people learned about in that era. That was in the 80s, you know, or the late 70s, 80s. That was a long time ago by computer standards, isn't it? But I still have one of these in a box somewhere, and it still works as far as I know. Last time I turned it on, it worked. Yeah, that used the Z80. Now, you notice that both the 8088 and the Z80 have the 80 number in it. Well, they actually do share a lot of the same instructions, and you can run programs that were written for this old computer here on today's IBM PC using what's called an emulator, which is a program that simulates another computer, because our computers today can run the software that ran on that computer at full speed, at even faster, in fact, than it ran on the original computer. But these are different models of computers, and obviously they were very different from each other. They weren't compatible by any standard. And for example, taking the TRS-80 with the Z80 in mind, when they came out with new models of that computer, there were several models. The programs had to be rewritten because the hardware changed from the different models. You had to have different versions. So when you bought a program, you had to make sure, oh, does this run on the Model 1, or does this run on the Model 2, or the Model 3, or the Model 4? They had different numbers. Yeah, they actually had those numbers for that particular computer. You had to make sure that it would run on those different computers. Time since then is the operating system has become more important to the programs than the computer that it runs on. Nowadays, your application software is written for the operating system, and so it communicates with the operating system and not so much for the computer hardware that's underlying it. The program doesn't need to know about the hardware it's running on anymore. There are thousands of different versions of the IBM PC today. Right? There are many manufacturers of personal computers that are compatible with each other, more or less. The thing that makes them compatible is, oh, they will run Windows. So if a computer will run Windows, and you get a program that's written to run Windows, it'll run on that computer. But the hardware could be very different that underlies. The underlying hardware could be have lots of different variations. So nowadays, programs are written for an operating system rather than hardware, whereas 30 years ago, it was written for specific hardware. And you can see the advantage of that is that allows me then to have the same programs running on different versions of the hardware, different processors, even different, totally different motherboards and so forth. Now, what's this thing called BIOS? Well, that was an innovation that IBM came up with. That was something that was a good idea, and we still do use this today. BIOS is when you get a computer motherboard, the computer itself, the part of the computer that has all the parts that connect to it, there is a built-in program that runs when you first turn on your computer called the BIOS, the Basic Input-Output System. It's kind of like an operating system. It is kind of an operating system, but it's built into the computer's hardware. When you turn your computer on, it's there right away. It doesn't need to boot up. There's no delay for this BIOS to start up, because it's there right as soon as you turn on the switch. The first thing the BIOS does is it tests the computer, and it starts to communicate with the hardware, and you can communicate with it when you first turn your computer on. There's a time where you can press a special key on your keyboard, one of the keys, like maybe the delete key or one of the function F keys. I know on this one's F2. When you first start up your computer, you can get the attention of BIOS, and you can talk to BIOS, and you can configure BIOS. And like if you add a new hard drive or something like that to your computer, or add more memory, a lot of times you talk to BIOS and check to see that BIOS recognizes it. Because if BIOS doesn't recognize it, then the operating system may not recognize it, because what happens is the operating system communicates with the BIOS, and then the BIOS communicates with the hardware. So that's how that works. Now, the reason why BIOS was created was to allow the operating system to basically have one version. And there would be a version of Windows, which you could run on a wide variety of hardware, but all of the operating system would know how to communicate with the BIOS, because the BIOS has a standard way of communicating. So what would change, though, would be the hardware. Different models of different computers would have different hardware, and they would then need to have a custom-made basic input-output system for that hardware that would know how to deal with different parts of that hardware. For example, when the operating system wants to talk to the storage system, the hard drives or the solid-state drive or whatever you have on your computer, the operating system knows how to communicate to BIOS, and BIOS then knows how to talk to that hardware, like the storage system. Or when the operating system wants to communicate with the video, it will send, a lot of times it will send things to BIOS, and then BIOS will communicate with the hardware to make something be displayed on a screen. Or when the operating system wants to get something from the keyboard or the mouse, it will communicate with BIOS, and then BIOS in turn will get that information. There are times when the operating system communicates directly to the hardware, because BIOS doesn't know how to talk to everything. BIOS doesn't know how to communicate with every single possible piece of hardware that you might put in your computer. You might put something in your computer that BIOS doesn't know about, a new piece of hardware, in which case then the operating system needs to have what's referred to as a driver. A driver is a program that communicates with a piece of hardware, a specialized piece of hardware, and allows the operating system to use it. So there are times when the operating system does communicate with the hardware directly through these driver programs. So you can kind of think of the drivers as extensions to the BIOS. That's really, in many ways, what they are. But they are programs that run inside the operating system. They don't run, they're not controlled by BIOS. So operating system does communicate directly to the hardware. What doesn't ever talk to the hardware is the application software. Application software does not talk directly to the hardware. It communicates with the operating system, and anything it needs, any communications that it needs to do, such as, say, putting something on the screen, getting something from the keyboard or mouse, getting something from the file system, it goes through the operating system to do that. So that's the layering. That's the kind of, and if you understand these layers, it helps you to understand how the computer works. And also, if something isn't working right, something is malfunctioning, then it helps you to understand how you might, what the malfunction, the nature of that malfunction, and how it might be solved, how it might be resolved. Now, what are some of the characteristics of an operating system? One of the characteristics of an operating system is the ability to multitask, to enable you to run more than one program at a time. If you didn't have an operating system, you would only be able to run a single program at once. You'd load the program into the computer and it would run. And that would be all it would do. It would run that one program and nothing else. Now that was like that I showed you that Commodore 64 a while ago, or that TRS-80. That's the way those computers worked. You loaded a program into it and it ran, but you couldn't run two programs at once, at least not in the early versions. Now, that wasn't because the hardware couldn't possibly do that. There was ways to make it do that, but at least initially they didn't have that capability. They later figured out ways to make multitasking occur on some of those old computers, but pretty much nowadays with modern operating systems, it's taken for granted that we can have many programs running simultaneously. And so that's called multitasking. And most operating systems today do support that. There are two versions of multitasking. One's called cooperative multitasking. And that is where when different programs are running, they give up control or give up the time that they're running in the computer to another program to allow them to run. So suppose you have 3 programs running, we'll just call them Fred, Harry, and Joe. What would happen is one program would run, let's say Fred here, and then it would pause itself, it would stop, and then say, give up and go ahead and let another program run. And then the next program run, let's say Joe here, and then Joe would run for a little while and then pause, and then Harry would get to run for a while, and then just keep doing that. And it's like a loop. And that is one way operating systems can work. Is that different programs run and then they give up their time to another program. This kind of method of multitasking was used in early versions of Windows and also Apple operating system. The Mac computer, the early version of the Mac, Apple Mac did this. It works okay as long as all the programs cooperate. If a program, though, say crashed or just wasn't cooperating, you have to be cooperative for this to work, and it decided to keep itself running and hog the computer, well, this kind of multitasking wouldn't work very well. So it would freeze up the computer or perhaps get stuck in one of the programs. It would work okay as long as the programs were cooperative. And so it actually is not a bad way to go as long as, like I say, the programs run cooperatively. Now, there is another way to run multitasking that eliminates that problem for the most part, and that's called preemptive multitasking. And that is where you allow several programs to run simultaneously, but you don't allow them to control how long they run. In other words, the operating system allows each program to run, and then it forcibly switches between the different programs. That's called time slicing. So each program doesn't have to worry about giving up its control. It doesn't have to tell another program that, or allow another program to run. It just runs as if it has the whole computer to itself, but in reality it doesn't. It just runs for a little while and then stops, and then another program starts running. It doesn't let another program start running. It is stopped. It is stopped by the operating system. And then in reality, your computer really, as long as it has just one processor, which many computers still do have just one processor, they really only run one program at any given instant in time. It's just that it switches between these different programs so fast that it appears that they're running simultaneously. Now, there are computers that have more than one processor. You can have multiple CPUs in a computer, and many models, later models that we have today, have 2 or 4 or 8 processors or even more. So if you have multiple processors, it's possible that they could each run a separate program at the very same time. And those are called threads, 2 different programs. Or you could take one program that has several parts to it and run different parts of that program at the same time, and allow that task to be split up among different processors. So that's another way of multitasking. Another aspect of the operating system is the user interface. I mentioned this a while ago, is that you can talk to the operating system directly, to the kernel of the operating system. And that's called the text line interface. And this is a feature of Windows, Apple, and Linux. All 3 operating systems have this ability that you can communicate directly to the operating system and send commands to it using your keyboard. Not so much the mouse, but mainly the keyboard. The mouse can be used sometimes, but for the most part, this is pretty much a keyboard command. You type in commands using different words and different syntax, or in other words, ways of listing commands, and then it will do what you ask it to do. The other kind of interface is the one that most people are familiar with, and that's the graphical user interface. And that's when people think of an operating system, they think of the graphical user interface. But really, the graphical user interface, whether it be Apple, Linux, Windows, whatever, the graphical user interface is really a friendly way to interface, to allow the user to communicate with the kernel in a friendly way, mostly using a mouse or a touch screen, something of that sort, so that using the computer is easier to do. You can actually do everything you want to do. Anything you can do with the graphical user interface, you can do with the command line. For example, say I'm in the graphical user interface and I want to delete a file. I could just take my mouse, click on that file, and select delete in the menu. There's a little menu that'll pop up. Well, I can do that in the text line command. I can go in and type in delete and the name of a file, and it will delete it for me. Or maybe using my mouse, I might want to move a file around. I can do that also with a graphical user. I could do that either with a graphical user interface, or I could use the text line command. In the text line command, I might use a command called move, or if I want to copy a file, make 2 copies of it, there's a command called copy. You can do those things with your mouse using the graphical user interface. And usually you can do it a lot quicker with your mouse, so it's very convenient to use a graphical user interface, and it's very intuitive and easy to use. And people that use computers that don't know much about the file system, but they understand this general principle. They understand the idea of folders and files that go inside folders and places to save things and that sort of thing. And that, by the way, is called the file structure, and that is another part of the operating system. The file structure is what organizes this data that's stored in the storage system. And we're pretty familiar, usually most people who use a computer have been fairly familiar with this concept of files. It really comes from mechanical filing, where people put things in drawers, in folders, in file drawers, in manila folders or whatever color they are. And so that's why you see the symbols of the icons that look like folders, paper folders, and you can put folders inside of folders, something you don't normally do with a real, physical file drawer. You don't usually put file folders inside of other file folders, although you could. It gets kind of, fat. Makes the file folders fat, but you can do that. Some file systems do that. But on a computer, you can do that. You can put file folders inside of folders inside of folders. Really, there's no theoretical limit to that. But usually, it just goes down, several levels. And then, of course, your files go inside the folders. And that's all part. And there's a thing called the root, right? The root of the file system is that which contains everything else, contains all the folders and contains all the files that are in those folders. And you can even put files at the root level of that's like the file folder, the drawer itself, right? The drawer of the file cabinet, if you will. Imagine that's the root. And in Windows, that's usually done by different drives. So you can have hard drives or solid state drives or flash drives, whatever, and each one of those has its own root. It's like a drawer in a file cabinet, so you can put files directly into that, or you can put it inside folders. That's called the file system, and that's similar in other operating systems too. Apple, Linux, they all use this similar system. If you were familiar with it from one operating system, you would look very familiar in another operating system. Now, how does the operating system keep track of all that? Well, that is part of a thing called the file allocation table, or FAT for short. We don't always call it FAT, F-A-T, file allocation table, but it's some kind of a record of where everything is stored on a storage device, whether it be a hard drive, a solid state drive, something like that. There has to be some type of a file allocation table, and this is actually some data stored on the hard drive or the solid state drive itself, and it's a special place where information about all the different files is located. And there are many versions of file allocation table. Just Windows has several versions. The original Windows had The early versions had FAT12 and FAT16. The 12 means 12-bit. It means that it used 12 zeros and ones to represent the location of the file. With 12 zeros and ones, you can have 4,096 different possibilities. With FAT16, you could have 65,536 different possibilities. But that's a lot of different possibilities. That's different locations where the things can be stored, the files can be stored. And with 32-bit, you have about 4 billion different possibilities. And then other versions of the operating system, these actually were used in Windows. These are used in other operating systems. And NTFS is the latest one. And it's really more or less a 64-bit operating system. So meaning that it has many quadrillions of possibilities. It's a big, huge number of, and it's such a big number, in fact, that there is no storage device that large yet. Nobody has ever built one that big yet. So it has lots of potential for the future. So if you use a new version of Windows, let's say Windows 10 or Windows 8 or Windows 7 or Windows XP even, those all pretty much use these later operating systems. Primarily, file allocation tables. They would either use the 32-bit version or the NTFS, which is actually 64-bit or can be that big. It isn't necessarily that big, but it can be. It's a very extensible file system, very large. It can handle huge, huge file systems. FAT32 is still used a lot today. It's primarily used on flash drives and things because it can handle up to 4 billion different locations, which is probably good enough for smaller storage devices. But then when you get to larger ones, you have to use the NTFS, which stands for New Technology File System. They could have called it FAT64, I suppose, but I think they decided to get away from it. It sounded a lot better to call it New Technology File System.
Also, the NT came from a long time ago when at the same time with the Windows born, the Windows create a new version, the Windows NT.
That's right.
That's where the NT came from.
That's where it came
for
from.
The servers.
Yep. Yeah, they have two versions of Windows. They had two Windows. They had.
They born and actually Microsoft remains using the versions for the professional version is based on the NT. Is for the familiar, for professionals, for more capables, and the other version, the regular version, is for home, for students, is the mostly with the 32. Usually came with 34 bits, but is with less capacity.
Yes. There were two different versions. Now they only have one. But in those days there was two. There was the home, like you said, the home computer version, and there was the professional version. And so what they did is they ended up making the professional version for everybody, and they called that Windows. Well, first it started out as it was called, like you said, Windows NT, New Technology, and that was the early version of it. And then there was Windows 2000, and then they called it Windows. Well, Windows Vista was the first one that combined the NT technology and made that became the operating system that was combining both the professional and the home version. Yeah, that's a good point. And then they had Windows 7 and Windows 8, Windows 10. That's where we are today, and that kind of shares that. Yes, sir.
Well, like certain programs, there's some newer versions of programs that do not work with Windows XP anymore. But I'm surprised that with the newest iTunes, it would not only have no support on XP, but they also dropped support for Windows Vista.
Yeah, so some of the newer software won't run on some of those older, like Windows XP, there are a lot of computers out there still running Windows XP, even though it's been discontinued quite a few years ago, right? It's still a lot of machines out there, and it still does run a lot of programs, but it's just they don't update it. If there's problems with the security on it, things like that, they're not updating it. Well, why don't we take a break here? Come back and wrap things up here about more stuff about operating systems. But let's take a little break on. I will break from we'll call that part 1 of our recorded slideshow. So I'll stop it.
Actually, when I came, and I arrived,